Hello everyone, this is Illuminating Dots. This is a summary of CBSE Class 10 Maths Chapter 1 Real Numbers, Exercise 1.2. The first exercise was about finding HCF using Euclid's division lemma. The second exercise is about finding HCF and LCM using the prime factorization method. So let's begin with the exercise, but before that, if you find this content useful and enjoy learning maths using my skills and logic interesting, then please subscribe to my channel and leave a like. Please. Let's begin. So the prime factorization method. Prime factorization method is something we have learned since standard 4th, so it needn't be explained again thoroughly, but I'll just give you a brief summary about it. So in prime factorization method, you are given a number, suppose x. You have to find the factors of x which are only prime numbers. Prime numbers include 2, 3, 5, 7, 11, 13, 17, 19, 21, etc. 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 Only prime numbers can be used to find the factors of the given number, none other than those. And for LCM and HCF, if we are given two numbers x and y, suppose the factors of x are 2 into 5 square into 3, which are all prime numbers. X is equals to this and y is equals to 7 into 13 into 5 square. So okay, let's take some smaller numbers. 7 into 2 into 5 square. So here the factors of x and y we have supposed are these. So for HCF, we take the numbers which are repeating in both the factors of the numbers, such as here 2 is present in both the ones. So we write 2 here only once, and 5 square is present in both the numbers. So we write 5 square. So only once we write 5 square because it's repeating only once. So 5 square into 2 means 25 into 2 is 50. And for LCM, we take the numbers highest power. So the highest power of 2 is 1, so we write only 2. The highest power of 5 is 2 here and here, so we write into 5 square. So 3 is only once and its power is 1, so we write into 3. And 7 is also once and its power is also 1, so we write only 7. We multiply it and what we get is the final answer. Let's begin. Okay, the most important formula for prime factorization method is, you have learned it in standard 5th or so. LCM into HCF is equals to A into B. Now A and B can be any integers, and LCM and HCF are the LCM of A and B and HCF of A and B respectively. So this is true forever if your answer is also correct. If your answer is also correct, yeah. If your answer is wrong, then you can't expect it to be correct. Let's start with the exercise. So exercise 1.2, first part. So 140, we factorize 140 as this. So 270, 235, 5, 7, 7, 1. So we wrote 140 is divisible by 2 completely, so we divided it. 70 is divisible by 2 completely, so we divided it. 35 is divisible by 5 completely, so we divided it. And 7 is divisible by 7, so we completely divided it. Now these are all prime numbers, so the factors of 140 are 2 square into 5 into 7. This was pretty easy. The ahead sums, I'll only solve one or two sub questions of each question, because this is just a summary. So if you have any doubt in any particular question, you can just comment me and I'll make sure to upload a video as soon as possible, or you can also mail me. I have given my Gmail account on my description, so you can mail on that account also. I'll reply to you as soon as possible. The second question, so the first part, it's find the LCM and HCF of the following integers and verify LCM into HCF is product of primes. So 26 and 91. So we factorize 26, we get 2, 13, 13, 1. We factorize 91, we get 7, 13, 13, 1. Now, so the HCF is 13, as both it is repeated in both, and LCM is 2 into 7 into 13, so which comes to 14 into 13. So 4, 3, 12, 3, 4 into 4, 1, so 281, which is 182. So our LCM is 182. Now the next part, we have to prove the formula. So LCM into HCF is equals to 182 into 13. So 182 into 13, so 6, 24, 345 into 281, so we get 6, 6, 3, 2. We get 2366. We get 2366 as the product of LCM and HCF. Now we find the product of the given numbers. So 26 into 91. So we get 91 into 26, 654, 218. So we get 6632. We get 2366. Now the LCM and the product of LCM and HCF and the product of the given numbers is equal. So we can write LCM into HCF is equals to 26 into 90 into 91. So this was easy. Let's go to the next question. So the third one, find the LCM and HCF of the following integers by applying prime factorization method. So the first question is 12, 15 and 21. So we factorize 12, we get 2, 6, 3, 2, 2, 1. And we factorize 15, we get 3, 5, 5, 1. We factorize 21, we get 3, 7, 7, 1. So the factors of 12 are 2 square into 3. The factors of 15 are 3 into 5. The factors of 21 are 3 into 7. So therefore the HCF is equals to 3, since it is repeating in all the numbers, and the LCM is equals to the highest power of 2 is 2, so we write 2 square. We write 3 as it is because its highest power is 1. We write 5 and 7 as it is. So 5 to 10, 21, 24, 42. So answer is 420. How I got this? So 5 into 2 is 10 and 7 into 3 is 21 and the remaining 2, so we get 42. So we multiply it, we get 420. These are some small tricks I use usually to make things work faster. And if you want such things, if you want to know such things, you can just comment me. I'll make sure to make one more video of such tricks and shortcuts only. Now the fourth question, given that HCF of 306 and 657 is 9, find the LCM of 306 and 659. So the HCF is equals to 9 and the numbers given are 306 and 657. So we use that formula itself. So LCM into HCF is equals to A into B. So LCM is equals to A into B by HCF. This is basic maths. I know I need not explain how I got this. So 306 into 657 by 9. So we cancel it. So we get 7 3. So 306 into 73. I get 18 9 357 42 4 73 21 8 3 3 2 2. So I got 22338. Now so the LCM is 22338. This was simple. Only that you need to be accurate in your calculations, nothing much. Fifth one, check whether 6 raised to n can end with digit 0 for any natural. 6 raised to n, can it end with digit 0 for any natural number? So 6 raised to n can be written as 2 into 3 the whole raised to n. When we expand it, we get 2 raised to n into 3 raised to n. Now this is the most important part of the question. 6 raised to n can be written as 2 raised to n into 3 raised to n. Now when it is given, so any number to end with 0 for natural number n, so the power is supposed to be n, so it should have 5 as its factor. Why 5 as its factor? Because when 5 is raised to any number along with 2, so it gives 10 raised to something, and which comes to 10 raised to n. So 10 raised to n will always end with 0, and 5 is a factor which is compulsory, and 2 is a factor which is compulsory. 5 and 2. So it has 2 raised to n, but it does not have 5 raised to n. So it will never end with digit 0 for any natural number. No matter how much you try, it won't come with digit 0 at the end. Now the next part, sixth one, explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite numbers. So 7 into 11 into 13 plus 13, if we take out 13 as it is repeating twice, so we get 7 into 11 plus 1, and 13 7 11s are 77 plus 1, so we get 13 into 78. Now 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 1, so we plus 5, plus 5, so we take out 5 cause it's common. So 7 into 6 into 4 into 3 into 2 into 1 plus 1, so we get 5 7 6 are 42 into 4 3 are 12 12 2 are 24 plus 1, which comes to 42 into 24, so 8 16 into 4 8, so I get 8 1008. Therefore 5 1008 plus 1, so I wrote therefore 5 into 1009. Now 13 and 78 is a composite number and 13 is a prime number. Here 5 is a prime and 1009 is a prime number. So here 13 and 78 is a product of prime and composite, and 5 and 1009 is a product of prime and prime. So when there is a product of any prime number to a composite number, the answer will always be composite number. and when there is a product of two prime numbers, it will always be composite number. Now if not go by theory and if we use basic logic, then if a number is a product of two numbers, then it will be a composite numbers, since two numbers are present as its factor already. So this was something basic logic and nothing much. Only what CBSE does is makes you think and uses it and makes easy stuff a little complicated. Nothing much in that. It's very CBSE. The seventh one, so there's a circular path around a sports field. Sonia takes 18 minutes to drive on field. Ravi takes 12 minutes. Start at the same point at the same time, go in same direction. How many minutes they will meet again? So Sonia takes 18 minutes. Ravi takes 12 minutes. So the basic logic is, if they start, they will meet after some time, not before they started. So when they meet after some time, we find the LCM, because LCM is least common multiple. So whenever there are two numbers and they will meet after, because multiple comes after the numbers, and HCF, because that's highest common factor is lower than the number or equal to the number, whereas multiple is equal to the number or greater than the number, and we want a number which is greater than the number. So we find the LCM. That's easy logic. So factorize 18, we get 3 square into 2, because that's 3 square is 9, 9 2s are 18, and we factorize 12, we get 4 3s are, so 2 square into 3. So the LCM comes to highest factor of 2 is 2, so we write 2 square into highest power of 3 is 2, so we write 3 square. So 9 into 4 is 36. So they will meet after 36 minutes of starting their round. So this was it for the whole exercise. Please make sure you subscribe to my channel, and please comment me if you have any query or any doubt. This chapter is really boring and interesting also, and this is the beginning of my YouTube career. So I don't know how it feels, but it's not like someone will expect. So please bear with me for few more videos, and please leave a like and subscribe to my channel for more easy maths, and thanks for watching.